finding the equation of a line. We need to be able to find the equation of a straight line if we're given the y-intercept and a point, or if we're given 2 points, or from a graph. If it's from a graph, then what you need to do is find two well-defined points. So don't go for a point that isn't right on the grid lines. Here they've given us 2 points, which is nice and easy. We've got the y-intercept here at 5, and we've got 5 and -3. If the intercept isn't right on a grid line, as it is here at 5, then you wouldn't go for the intercept. And but look, this one here would be a good point if you were looking for one, right there on the x-intercept, because it's quite clearly at 3. So you're looking for where the points are, if you don't have them, that are really clear integer points. And your strategies are, of course, that we're going to find the y-intercept and the gradient. So, of course, the y-intercept, I have the point 0, 5. So to find the gradient is y2 minus y1 on x2 minus x1. Or, of course, since you have the graph, you can just do rise over run, because that's a drop of 1, 2, 3, 4, 5, 6, 7, 8. A drop of 8 and a run of 5. So, oh, sorry, my writing's getting a little small there. So that's fine if you wanted to get the gradient with rise over run. Or, of course, you're fine to label your points. Always do label them. You're far more likely to make a mistake if you skip labeling them. Substitute your values in. And I've got, of course, -8 over 5. So I've got the gradient. It's a 5. Leave it as a fraction if it's not going to come out as a whole number. And I've also got the y-intercept. So once you've got the gradient and the y-intercept, either use the form y equals mx, sorry about the bell there, plus b, or y equals a plus bx, remembering that our b there is our gradient. Either one is fine, and substitute your two values in. Y equals -8 on 5x plus 5. In this case, it would be y equals 5 minus 8/5 of x. Either one is fine, whichever way you would prefer to set your line out. Now in this situation, sorry, I'll zoom in a little bit, you're not seeing me well there. Find the equation of the line passing through 2, 1 and 4, 10. So to do this, we still start by finding the gradient. And we'll need to do that by using the formula. Substitute your values in. Okay, so I have my gradient. This is going to be annoying. Now, I don't have a y-intercept, but you'll remember that the y-intercept, if I go back to my graph so you can see, the y-intercept is the value when x is 0, because x has to be 0 for the line to be on the y-axis. So, my second step is to find the y-intercept by substituting in x equals 0. That is not my second step. We find the y-intercept by substituting in a point and solving the equation. I'm sorry, people. It's one of those mornings. So we might as well pick this one because it looks like a nice and easy point. X is 2, y is 1, and the line I've got so far is y equals mx plus b, or if you prefer, y equals a plus bx, and I've got the gradient. So I substitute in the point and the gradient and solve. Y is 1, gradient 9 over 2, times x, which is 2, plus b, which is the y-intercept that I want to find, or c, I'm sorry, whichever one we use there. Now this was nice and easy because divide by 2 times 2, that just cancels out. 1 equals 9 plus b, take away 9 from both sides, b equals negative 8. So my y-intercept is negative 8, and now it's just a case of whichever one we're using. Let's use y equals a plus bx. Now, one of the problems, this is why we should always use c here, because we get our b's mixed up. It doesn't matter which one you're using, you've just got to remember that this is the constant on its own, and that's the gradient. It doesn't matter which one we're using. I'm using both so that we get used to whatever turns up in a question. So that is y equals constant on its own, negative 8, and plus 9 over 2x. When it's a negative out the front, we might be better off having gone with y equals mx plus c, so that would be 9 over 2x minus 8. But they're correct either way, and it's simply a case of when you're finding the equation of a line, get the gradient, get the y-intercept, and substitute it in to either that form or that form. It doesn't matter which order we're in.